So for question 2, right, for the first part, you are asked to show given two functions f and g. Number 1, you're supposed to show that f inverse exists and show that f is self-inverse. Okay, so for a self-inverse function, basically they have given you that you want to show that the function of f, right, function of f, right, should be equals to f inverse. Okay, so with this, right, what you need to do is you need to draw out the whole function of fx itself. Okay, in the given domain, you can see that any horizontal line when y equals to a, where a is real, intersects the graph at most once. Okay, so this is the definition of having a one function. So to show one function, one of the very direct ways, you need to use the horizontal line test. To do the horizontal line test, you need to draw out the graph. Okay, and so from this, it follows that f inverse exists. So number 1, you have to really draw the graph, show that the existence. Okay, show that any horizontal line, write out the correct explanation in order for you to hit the method marks. Okay, yeah. And also there are two ways to describe one function. To show that horizontal line test, you need to not only write the graph, but you draw the graph, but you also have to incorporate the relevant explanation. Okay, then how do we show that f inverse f is self-inverse? Question, you can see it's the same. What is the domain of f? Okay, and what is the range of f? They are actually the same. Both will give you the fact that they are both equals to, right, basically x is real, okay, but x is not equals to 3. All right, so both of these are the domain of f is equals to the range of f. So basically we need to show that f equals to f inverse. To show that two functions are equal, right, remember the function does not only have the rule, the function also must come with the domain. So a lot of you maybe just show that fx so-called is equals to f inverse x, but also you need to show that the domain of f must be equals to the domain of f inverse. That's also a key thing. All right, so a lot of you actually got this part, okay, but you need to show that there's evidence that domain of f inverse equals to domain of f. So what is the domain of f inverse? The domain of f inverse is basically the range of f. Okay, and you can see the range of f actually gives you the same thing. It's actually equals to the domain of f. Okay, by observing this is a self-inverse function. Okay, so next so I also need to show, hence find the value of 2003 5. Okay, so how do I go about doing this? Okay, so basically the 2003 5, because we know that it's a self-inverse function, so the f inverse fx, okay, we know that it's equals to x. In this case, basically because it's self-inverse, I can say that if I have f of 2003 or 5, right, correct, okay, this is the same as so-called f of so many times of 5, and we know that because it's self-inverse, f is the equals to f inverse, so I actually can replace this, I put an inverse, I replace this, I put an inverse, so you're going to basically get f inverse f, f inverse f, so until you have so-called 2002, so that's basically like 1001 pairs of f inverse f, followed by the last one, f of 5. Okay, so all these, right, do nothing to the function because they basically give you the identity function, and you just end up with f of 5, which by substituting this value into your original fx, you will just get 4. Okay, so remember with f inverse f, they actually so-called in a sense they cancel out each other lah. Okay, but we don't use the word cancel, basically because you take f, because f is equals to f inverse, therefore if I take, for example, f squared, this is the same as f inverse f, right, which is basically just the identity function. Okay, and the next part, I need to sketch on the same diagram the graph of gx and g inverse. Okay, this is for part 3, all right, sorry, for part 2, sorry, I need to find the expression for g inverse x. So to find the expression for g inverse, because g now you can see is like a modulus function, so to do this properly, it's better for us to split it in accordance to the relevant domain, right, so make it like piecewise, and then you find the inverse based on this. So it's safer this way, so we split it into the two domain, all right? And with that, because here what we're doing is, remember, modulus of fx can be equals to fx, right? Or the negative of fx, right? If fx is positive, this one is if fx is negative, right? So from here we just expand, all right, and we find make x the subject, and we find the relevant rule for g inverse x. And remember that because most of the time when you do square root, you're going to get a positive and a negative rule, and you have to decide that you have to reject one of them. So in this case, who do you reject? Okay, I'll leave it to you to think about it, but remember the rejection falls by looking at the domain of your g inverse, right? The domain of g inverse is a range of g, so we have to know which one to reject. So in this case, we're rejecting one, we're taking this as the rule. Okay, so this is your g inverse x. Okay, and next I need to draw in part 3. Okay, I need to draw the same graph diagram, the graph of gx and g inverse. Okay, so okay, most of you are able to, this question is quite well done. Most of you are able to get this question correct. Okay, so only thing is probably you may have gotten some the domain wrong or the graph wrong. Okay, so illustrate the relationship between the two graphs, label the x-intercepts wherever possible. So some of you may have forgotten this, so you need to label the intercepts, all right, and write down the set of values that satisfy the equation gg inverse equals to x. Okay, so gg inverse, where is the graph of gg inverse? The solution. Okay, basically, right, for gg inverse to x, so you must remember that gg inverse, right, follows the domain of gg inverse, right? Remember, it's actually a composite function, so equals the domain of g inverse. Okay, where x, so the towards the domain of g inverse, right, basically x is from 0 to infinity, or x is greater than equals to 0, right? So because where is the domain of g inverse, so remember it's actually here. So this is the answer to part 3. Okay, then I want to show that fg inverse exists. What do I need to do? That's for part 4, right? I just need to show that the range of g inverse must be a subset of the domain of f. Okay, so this is what we do. We establish the range of g inverse, we establish the domain of f, and then we show that it's a subset. So this question also is generally quite well done. Okay, last part, we need to recognize a range of fg inverse. So some of you did the mapping method, so you basically map the range of g inverse into fx, so that is fine. So you know that the range of g inverse is negative infinity, negative 1. You map this into the graph of fx, and you got your final answer to be 2.5 inclusive to 3. Alright, so this is the range of fg inverse by mapping the range of g inverse into the domain of f to get the range of fg inverse. Okay.